So solving systems of equations, using those to solve problems. Whenever you're talking about solving problems, what they're really talking about is word problems. So sometimes word problems are going to require that we set up a system of equations in order to figure out what those variables are. So to read it, it's often necessary to set up two equations with two variables to solve a problem. Each of the problems can be solved using a system of equations. Follow the steps to solve each problem. So these are the steps that you're going to need to solve word problems. So first, read the problem twice to determine the context of the problem and to identify key components to the problem. There's often extraneous, which that's just a fancy word for unnecessary, information in the problem. So you need to be careful to make sure you thoroughly understand the problem. So this is where you would want to underline or highlight the important stuff. So you want to identify the unknown values and assign different variables to each. Then you set up a system of equations to identify each given fact. Solve the system of equations using an appropriate method, so graphing or elimination or substitution. And then you're going to answer all the questions in the original problem. Last but not least, check your answers in the original problem. You may have set up an equation incorrectly. So if you check your answers using the equation you made, then it might indicate that you have a correct answer when you do not. So we've got to go back to the original problem and try to plug things in to use it. So here's an example. It's just a one-sentence word problem. Find two numbers whose sum is 64 and whose difference is 42. So again, let's read that one more time. Find two numbers whose sum is 64 and whose difference is 42. So what are some important things? Well, we want a sum, right, and a difference. So those are the two different types of equations we're going to have. We want two numbers, and I don't know what the numbers are. So the problem's asking us to find two numbers that when they're added, they equal 64, but when they're subtracted, they equal 42. So what we're going to do is we're going to let x equal one of the numbers, and we're going to let y equal a second number. And then we're going to set up a system of equations based on the information. So x plus y, so the two numbers added together, is 64. X plus y equals 64. When the numbers are subtracted, x minus y equals 42. So the difference between the two numbers is 42. Then we're going to solve the system of the equations using any appropriate method. So in this case, the coefficients of y are already opposites. So it really sets it up well to use elimination. I can just add these up, and I get x plus x equals 2x. 64 plus 42 equals 106. To solve for x, I divide both sides by 2, and x is going to equal 53. Then I use that to figure out what my y value is. So I picked the first one, and I get x plus y equals 64. So 53 is the value we found for x, so 53 plus y equals 64, and I get y equals 11. So the numbers are 53 and 11. So we have to check the solutions. We're going to go back to the words of the problem. Find two numbers whose sum is 64. So does 53 plus 11 equal 64? Yes, it does. And whose difference is 42. Does 53 minus 11 equal 42? And it does. So we know we have the correct answer. So another example would be the sum of two numbers is 6. 3 times the greater number equals the sum of 4 times the lesser number increased by 6. Find the numbers. All right, let's read that again because that was a lot. The sum of two numbers is 16. 3 times the greater number equals the sum of 4 times the lesser number increased by 6. Find the numbers. So we know that we are dealing with two numbers. If you add them up, they've got to equal 16. If we multiply one of them times 3, I need to set that equal to the other one times 4 plus 6. So the problem's asking us to find the two numbers. So we're going to let x be one of the numbers and y be the other one. So the first thing we're going to set up is that x plus y equals 16. The second equation says that 3 times the first number equals 4 times the second number plus 6. So this is our system of equations. So if you use substitution to solve this problem, I could get either one of these variables alone very easily. We picked x this time, so I subtract y from both sides. So if x equals 16 minus y, then I have 3x equals 4y plus 6. So I plug that back in for x, and I get 3 times 16 minus y equals 4y plus 6. Distribute, 48 minus 3y equals 4y plus 6. Add 6 to, or excuse me, subtract 6 from both sides, add 3y to both sides, solve for y by dividing by 7, and I get that y equals 6. So x plus y has to equal 16 and y equals 6. So I plug it in and I find that x equals 10. So my numbers are 6 and 10. So we need to check the answers in the original problem. The two numbers total 16. That's just 10 plus 6, and yeah, that's 16. 3 times the larger number is 4 times the smaller number increased by 6. So 3 times 10 is 30. 4 times 6 is 24, then you increase that by 6, and that's also 30. So 30 equals 30. So since the arithmetic works for both facts in the original problem, we know we have the correct answer. And we'll save the other examples for in class.